Hello friends, welcome to Susan and John MathTube. We are in lesson number 3 in grade 12 exam preparation. And in this lesson, we are going to learn one of the most important things, that is chain rule, in a very easy way. Anyway, we are done with planning, formulae, basic differentiation, etc. I hope you're practicing along with the videos with more problems from some textbook. Okay, and once more, don't forget A, B, C, etc. up to LMN are constants, alpha, beta, gamma are constants, X, Y, Z are variables, U, V, W are variables, etc. Okay, now look at this. Suppose you have sin x multiplied by log x. You will apply product rule to find differentiation. Now imagine we have sin log x. This is actually a chain function. It is very easy to identify because every function will have an input variable. And usually mathematicians will keep the input variable as x, t, u, w, etc. Now imagine the input variable gets deleted by or replaced by another function that is called chain function. Look at this. I have a function log x. So I'm going to delete x and I'm going to put log x to the power 3. This is a chain function. Or I have square root of x. Instead of square root of x, I'm keeping root under sin x. So a very easy way to identify chain function. Look at this. I gave you all the formulae with the input variable called x. Now imagine this x gets replaced with other functions. For example, sin x the whole power n, or maybe root under tan x. This is called chain function. Y is equal to sin log x, and the question is find dy by dx. The method is so simple. All you have to understand is this is sin something. You have only two options. Is it sin something or is it sin x? If it is sin x, it is a basic function. If it is sin something, it is chain function. The derivative of sin something is cos the same thing multiplied by. This is from chain rule in class 11, which is derived from first principle. Always remember multiplied by. Sin is gone. What's the derivative of log x? 1 by x. That's it. Okay, I'll give you another question. Y is equal to root under tan x. So I told you, are you able to see root x or root something? Root something, obviously it is not root x. What is the derivative of root x? 1 by 2 root x. So what is the derivative of root something? 1 by 2 root the same thing multiplied by derivative of that something. So let's apply dy by dx once more. It's super easy. What do you see? Root something. So answer is 1 by 2 root the same thing multiplied by, you can forget about the root now. What's the derivative of tan x? Sec squared x. As easy as that. Now look at this. Y is equal to log sine e to the power x. Let's make it like more horrible. So we have log of sine of e power x. If you want, you can keep bracket. So dy by dx equal to, okay, look at this. What do you see on the board? Do you see log x or do you see log something? Obviously log something. If it is log x, derivative is 1 by x. If it is log something, the derivative is not 1 by x, it is 1 by something. Don't stop with that. Multiplied by derivative of that something. Who told you? Chain rule. Okay, so this becomes 1 by sine e power x multiplied by, what's the derivative of sine something? Can you see? Log something becomes 1 by. Log is gone. Now sine something, it is not sine x. So cos the same thing. Sine is gone. What is the derivative of e power x? Can you see it's e power x, not e power something? Done. So let's go for one more question. Y is equal to tan inverse x to the power 4. Let's make it a little bit difficult. Question number 1. What is the derivative of tan inverse x? 1 by 1 plus x square. By the way, by now I hope all the formulae are in good condition. Okay. Now, what is the derivative of tan inverse? Because I cannot see tan inverse x. What I see is tan inverse something. So the derivative will be 1 by 1 plus same thing squared. Don't stop with that. Multiplied by 4x to the power 3. Now you can simplify. This can be written as 4x cubed divided by 1 plus x power 8. Okay, let's go for another problem. Y is equal to tan inverse log x. Okay, great. What's the derivative of tan inverse x? 1 by 1 plus x square. But sadly, I cannot see tan inverse x. All I see is tan inverse something. So what's the derivative of tan inverse something? 1 by 1 plus same thing squared. Multiplied by tan inverse is gone. What's the derivative of this something? 1 by x. Now simplify. Okay, I'm going to make one question which might confuse you. Y is equal to tan x squared multiplied by e power x. Okay, so dy by dx equal to, tell me, what do you see on the board? Do you see tan x or tan something? Obviously tan something. So the derivative will be sec squared. By the way, it's not tan inverse, tan. What's the derivative of tan? Sec squared. X squared into e power x. Multiplied by, come on, what's the derivative of tan something? It is sec squared, the same thing, multiplied by derivative of that smiley. Oh, now I have to apply product rule. Can you see a product rule here? Earlier it was chain, but now it started as a chain, but inside it's a product. So I'll get x squared into e power x plus e power x into 2x. If you did not understand this, that means your lesson 2 is pending. Make sure your product rule is in good condition. Anyway, simplification. Simplification so simple. Sec squared x square e power x, and then e power x is common, x is common. I'll get 2 plus x and put it in the proper order. Multiply everything. Okay, let's go for one more problem. Y is equal to x square plus tan x the whole power 100. Okay, come on, come on, come on. Do you want to try? Then pause it and try it, and I'll write the answer here. I can see x to the power n. Can you see variable to the power number? X to the power n is n, x power n minus 1. So something to the power n. So I'm going to get, can you see this is like something to the power 100. So 100 into same thing to the power 99. Don't read the stuff inside, that will confuse you. Multiplied by, okay, that part is an addition, a natural. So the derivative will be 2x plus sec squared x. Okay, we'll stop chain rule here. I'll be back with lesson number 4, in which we'll revise implicit. So till then, my friends,